Baden, you have your hand out? You can have your group mate out. Listen, about the classwork, I don't just do this for fun. I do it because I think it's important. What's the y-intercept of this one?
0, 9.
0, 9. That's the first step. Y-intercept this number here. What goes after y-intercept? What's the next step? Axis of symmetry. You have your hand out, Paxton? Izzy, what's the formula for axis of symmetry? Yes. Allison, can you tell me A, B, and C?
A is 1, B is -6, and C is 9.
So we'll do -6. There was an issue, I think maybe with homework, where a lot of students have it wrong because of a negative sign. You get one negative sign wrong right here, and your whole problem goes awry. Like, it does not work out. So you have to be really diligent and careful when you plug in a negative. 2 negatives make a positive. 3. This is your dashed line. Draw your dashed line. No, it's just like the funny one thing after another. What happens, Talon, after you get your axis of symmetry? I'm gonna do one thing before the chart. Cassie? Find the vertex. How do you find the vertex? We'll take the x out and put 3 in. I'm gonna walk around and see who's got it. Alright, 9 minus 18 plus 9. -9 plus 9, 0. There's our vertex. X is 3, Y is 0. Who's got a question about why their math worked out differently? I'm gonna get some new markers. Just maybe. I want a dashed line at 3. I want a point at 9. So the axis is correct. Well said. You can write it down. Fact. So were you successful at making a table? So every table's different. In the middle, I'm going to put whatever I found for the vertex. The vertex is the middle of the graph, and it should be the middle of my table. What did you do? Which is? There's your table. Get a thumbs up if you created the correct table. Okay. Okay, did anybody back there, Jacob, Aiden, did anybody back there plug one in? Did you, Aiden? What'd you get? 4. Nathan, did you plug 2 in? What'd you get? Nick, P, did you plug 4 in? What'd you get? Oh, that's looking promising. Alright, did anybody plug 5 in? Okay, Mark. 4. That should happen, so that's good. Does anybody have a question about the work for any of those? Your number didn't come out right? Take a look at our picture. So there's some pretty consistent dimensions when it comes to this parabola. Has anybody picked up on the pattern for the majority of the parabolas you've done? It's the same shape every time. You got it? What do you do? Like, can you identify the pattern with these points? Okay, what do you? They're symmetrical back and forth. Most of our parabolas have had the same proportion. They're proportionate. Is he? Have you seen it? No. Yes. Yes, this is happening. Every time the leading coefficient is 1, it's the exact same parabola. It's just showing up in different parts of the graph. So here's the center. From here, the next point has always been up 1 over 1. And the next point has always been up 4 over 2. I know the next point would be up 9 over 3. And after that would be up 16 over 4. It's x squared equals y. That's happening every time. This same shape we've had. And so you can start to know the shape, get your vertex, and just get the other points because you know it's over 1 up 1, over 2 up 4. That's only true if there's a 1 in front. Has anybody noticed it? You will. You will notice it more now as you do it. What's the answer? We haven't even done it yet. So it says solve by graphing. The work is here. I didn't show my work here. I would want you to for these 2 points. But this is, we got a graph. But we still don't have a solution. What's the solution? 3. Box it. This is the answer. All that work for this one number. So yesterday it was discussed that intercepts are solutions. So wherever our parabola hits the x-axis is a solution. So right here, most of our parabolas are going to have 2 solutions. If this was down a little bit, it would cross in 2 places. If it was up at all, it would not cross at all. Right here, 1 solution. Just touches the x in 1 place. So yesterday you were supposed to graph, and so you found solutions. Number 2, solve by graph of factoring. You solve it. That's what I'm saying. did you go? No, same problem.
Oh, it's the same.
We're going to do the same problem, and we're going to solve it a different way. The truth is, we're going to solve quadratics by factoring, completing the square, quadratic form. We're going to solve quadratics 4 different ways, doing the exact same thing. Some ways are good for some things, and some ways are good for other things. So, we already factored this year, back in August. We need numbers that multiply to 9, positive 9, and add to negative 3. Multiply to C, add to negative 6. And add to B. Remember doing that? That's factoring. Negative 3 times negative 3 is 9. Negative 3 minus 3 is negative 6. So once you find your numbers, you put them in parentheses. X minus 3. So this is called, I got my y equals, this is called standard form. Let me write this for you really clearly. These are equivalent. They look the same when they're graphed. This one's called factored form. It's the same problem in a different form. Also called intercept form. Because factors show where the x-intercepts are. So if I want to factor this, or to solve it further, I would put a 0 in, because at all x-intercepts y is 0. And then I take this little factor and I make it its own equation. I say x minus 3 equals 0, add 3 to both sides, and x is 3. You make this little bit equal 0, solve it however it needs to be solved. This time it's adding 3, and there's your answer. Same solution we got when we graphed. So the answer to factoring is the x-intercept to graphing. You'll find that factoring is shorter, quicker. Factoring is easier to do than create a whole graph. So students generally prefer factoring to graphing. Any questions? Okay, just get out your homework. I'll put the answers up.
That's exactly what I'm saying. I got fraction for x squared. I thought you were able to do it with fraction. Like I appeared before this. I have work. I can't write anything down in the Three periods. So that's gym class, we can't read anything. Then science class, which I'm not allowed to do other things. And then before some class, and then before that, I have lunch. You're gonna do it. You're gonna give it to me.
Why did you go that far over? You could have just done 0 and -1. That's the real question. Your vertex is supposed to be +1.
I realized I used the wrong answer.
You're number 7. A lot of people got 7 wrong. Couldn't do it.
I got it right.
That's a referral. That's a referral, man.
I literally wrote the right vertex, but still put it at negative. I wrote the right vertex and everything and put it down 0. I put it because I had it before, but then I did it negative. That's the stupid thing I did in my whole life. And that's why for me, I got +3 and I put negative because it's just
For the rest of the class, you're working on this handout. Whatever's not done in class is homework. This is not graphing. We are done graphing. We are factoring. The whole thing. You're looking for numbers that multiply to the last one and add to the middle one. You're putting it in parentheses and you're solving it.
The last 11 with us.
not do your work on this tiny piece of paper. Do your work on a different piece of paper. No, it's class, right? You got 20 minutes. Let's see if we can. Let's hustle. I'm giving you an opportunity to practice and further your skills. Is that what you say to your coach?